Welcome to Ask and Learn.
Alright, guys, in order to solve this problem, we first need to find the dew point temperature of the air, that is the TDP. So, for that, we will first calculate the water vapor pressure from the given relative humidity, that is 70%. Phi 1 is equal to 70%, and the pressure Pg at the given temperature, that is T1, is equal to 32 degrees centigrades. So, we know that PV1 is equal to phi 1 into Pg1, and that is equal to zero point 0.7 multiplied by 4.76 is equal to 3.332 kilopascal, and TDP is equal to 25.8 degrees centigrades. So the temperature of the cooled air is T20, T2, that is equal to 20 degrees centigrades, which means there will be some condensation of water in the cooling process. To solve this problem, we will first need to calculate some of the needed parameters from the given ambient pressure, that is P is equal to 88 kilopascal, and the calculated water pressure PV1. We can calculate the air pressure, that is PA1 is equal to P minus PV1 is equal to 95 minus 3.332 is equal to 91.668 kilopascal. Now we will also need the absolute humidity W1, enthalpy H1, and the specific volume V1 for the calculation. We will use the given temperature T1 and the pressure P1 and PV1 and PA1. We will also need the enthalpy of saturated vapor, that is H1 Hg1 is equal to 2550 kilojoules per kg. Now, guys, we have W1 is equal to 0.622 into PV1 divided by P1 minus PV1, and that is equal to 0.622 multiplied by 3.332 divided by 95 minus 3.32332, and it's equal to 0.0226. So H1 is equal to Cp into T1 plus W1 into Hg1, and that is equal to 1.005 multiplied by 32 plus 0.00226 0.0226 multiplied by 2550, and H1 is equal to 89.79 kilojoules per kg. So guys, we have V1 is equal to RA into T1 divided by PA1, and that is equal to 0.287 multiplied by 305 divided by 91.668 is equal to 0.955 cubic meters per kg. So from the given velocity of air, V1 is equal to 120 meters per minute, and the radius of the tube R is equal to zero point 0.2 m, and the specific volume V1, we can calculate the mass flow rate of the air, that is M is equal to V over V1. So we have V1. So we have V1 into R square into pi divided by small v1, and that is equal to 120 multiplied by zero point 0.2 into pi divided by 0.955, and it's equal to 15.794 kilojoules per minute. So guys, the next we need to repeat the calculation for the next for the exit point. For the calculations, we will need the relative humidity, that is phi 2 is equal to 100%, and the temperature T2. So first we need the vapor pressure Vp PV2, and from it the absolute humidity. So PV2 is equal to phi 2 into Pg2, and that is 1 into 2.3392 is equal to 2.3392 kilopascal, and W2 is equal to 0.622 into PV2 divided by P1 minus PV2, and that is equal to 0.622 minus 2.3392 divided by 95 minus 2.3392, and the answer is 0.0157. So next we can use the absolute humidity W2 to calculate the enthalpy H2, and we can also calculate the specific volume. So H2 is equal to Cp into T2 plus W2 into H2, that is equal to 1.005 multiplied by 20 plus 0.0157 multiplied by 25, 137.4. This is 2530 37.4 is equal to 59.94 kilojoules per kg. So guys, moving further, PA2 can be calculated as P minus P2, and that is equal to 95 minus 2.3392 is equal to 92.661 kilopascal. So moving further, we have V2 is equal to RA multiplied by T2 divided by PA2 is equal to 0.287 multiplied by 293 divided by 92.661, and that is equal to 0.908 cubic meters per kg. So for part A, we know the process is a closed system process, and we can use that to calculate the mass flow rate of the condensed water. So MW is equal to M into W1 minus W2 is equal to 15.794 into 0.0226 minus 0.0157, and that is equal to 0.109 kg per minute. So we can now use the energy balance equation to calculate the heat transfer rate, that is Q. So for the calculation, we will also need the enthalpy of condensed water, that is HW is equal to 83.915 kilojoules per kg, and Q is equal to M into H1 minus H2 my minus MW into HW. So putting the values, Q is equal to 15.794 multiplied by 89.79 minus 59.94 minus 0.109 into 83.915. So the value Q is equal to 462.3 kilojoules per minute. So now we move on to part B. So from the calculated heat transfer rate, we can calculate the mass flow rate of the cooling water, MC. So for the calculations, we will need the given temperature difference, that is delta T. Sorry, it's let me write it in black color. Delta T is equal to 6 degrees centigrade. So we have MC is equal to Q over Cp into delta T, and that is 462 divided by 4.18 multiplied by 6, and the answer is 18.43 kg per minutes. So moving on to the third and the final part of this question, we can use the calculated specific volumes V1 and V2 to calculate the exit velocity V2. So we have small v2 over small v1 multiplied by capital V1, and that is equal to 0.908 divided by 0.955 multiplied by 120. So guys, the answer to V2 is equal to 114.0114. This is 4.09 meters per minute. So guys, these are the answers to this question. I hope you have easily understood all the calculations and the formulas. Thank you very much.